All right, we already know that there's something different, something special about the group 18 elements. And what is special about them is their outer level of electrons. It's full. And by having that full outer level of electrons, they have a very high stability. And what goes along with high stability is low energy. So that's kind of how the universe operates. The universe would prefer to have low energy, just like a rock on top of a hill would be more stable if it rolled down to the bottom. It would have less potential energy there. So the other atoms on the periodic table would like to become like the group 18 elements. So for instance, if you were oxygen or fluorine, you would want to gain electrons. So you'd want to gain electrons, and you would like to become like neon. Well, what about somebody over here, someone like sodium? Well, he could gain a whole bunch of electrons and go that route, but what seems easier, what would take less energy, would be to go the back way and lose one electron and become like neon. So that explains why on the periodic table, these guys over here, the metals, tend to lose electrons, and then the non-metals over here tend to gain electrons. But that's stuff that you already know, so that's kind of a review. Okay, so let's go really simple and let's talk about hydrogen. Hydrogen has one proton and one electron going around the outside. And I just feel like doing some shading here, so, and then the electron going around the outside would be all over the place or out here. Okay, so what is it that keeps the electron going around the proton? Well, it is the force of electricity. So the electric force is responsible for keeping the parts of an atom together. So how strong is that force? Well, you can solve an equation. It's not a very hard equation. It's called Coulomb's law. You solve for a force, and there's a constant, and these are the electric charges, and there's the distance. So when you solve this equation, you figure out how much attraction there is between the positives and the negatives. And that's the topic for another quiz, so we'll be gone. This will be gone for now. So let's say that we've got two of these hydrogen atoms. So I've got another one sitting somewhere over here. Let's say we've got one here, and it also has an electron going around the outside. Do some shading here, just for the heck of it. There's our proton. So how do these two atoms feel about each other? Well, this positive, we already said, likes his negative. They attract. But this positive would also feel an attraction toward this negative. And likewise, this positive would feel an attraction toward that negative. So just by these atoms being, somewhere near each other, maybe even not so near, they are actually going to feel some amount of attractive force for each other. They are going to feel a little bit of love. So what I want to do next is I want to talk about that attraction that they feel for each other, and I'm going to put it on a graph. So I'm going to draw a graph really quick here. Okay, so here's my graph. On the y-axis, I've got potential energy, and I've got distance on the x-axis here. So let's say these two atoms are some distance apart, quite a ways apart. Well, according to Coulomb's law, if you're far away, you're not going to have a very strong attraction. So you're going to have a point out here. But if these atoms come closer together, as the distance gets smaller, they feel more and more attraction. So you think you get a sense of where this graph is going. But before we follow that, let me jump to the other extreme. Let me jump to what would happen if we took these two atoms and we brought them super, super close together. If we mushed them way close together, so these two protons were right by each other. Well, in that case, if they're too close together, they're going to repel. So that's going to be a dot way up here. There's going to be a lot of potential energy, and they're going to repel each other. So as they repel each other, they start to move apart. So if you follow this line and this line, where do you wind up? You wind up with something like this. So down here at the bottom, there's kind of a special place, and that spot is where you get a chemical bond. So at a certain distance, these two atoms are going to be very happy with each other, and they are going to have a very low potential energy. And remember, the universe likes to have high stability and low energy. So the universe is pretty happy with the atoms being this far apart. So let's say that they have gotten together. Here they are. Here's one atom, and here's the other atom, and they've overlapped. They're sharing their electrons. And they're at this certain distance where the potential energy is the lowest. Well, what would happen if I wanted to tear them apart? Because they're not going to come together, they're not going to fall apart on their own because they're very stable. They're pretty happy where they're at. So I'm going to have to do something to get them to come apart. I'm going to have to pull on them. I'm going to have to add some energy. I'm going to have to actually do something. So I'm going to have to put energy in. So energy in will break a bond. So that's called endothermic, by the way. Okay, so by putting energy in and pulling these two atoms apart, breaking that bond, what have I done? I have increased the distance and I have put in energy. So that means then that when these two atoms are apart, they have more energy than they would like to have. So let me draw them really quick apart here. There's one and here's the other. They are apart. And this is just like they were when we got started. So that means that these solo atoms just hanging out alone, they have too much energy. They'd like to have less. So if I let them go, they're going to feel some attraction for each other, and they're going to come back together. And when they come back together to form this molecule again, it's called H2, by the way. It's one of the diatomics. That's a hydrogen molecule. You already knew that. Anyway, when they come back together, what's going to happen? Well, think about it. What's going to happen is the energy that I put in to tear them apart, those atoms still have that energy. So when these atoms do get together, what's going to happen is you're going to form a bond, and energy is going to come out. And that is called exothermic. So one of the big pictures here is that when you break a bond, that is energy in, and that is endothermic. And when you make a bond, that is energy out, and that is exothermic. And this is all closely related to this graph of potential energy. And at a certain distance, you get a bond where the atoms are the happiest or most stable.